Hello guys, so we are in the last class we were discussing about lithography, right? And now what we will see that step by step a lithography process where we will generate a particular desired structure. So let's see, let's assume this is the structure we need to create. So this is the structure. I will be drawing both the top view and the cross sectional view. So while you are making this kind of diagrams or designing any of these kind of devices, we need to understand what is top view and what is cross sectional view. So to explain that, I will give this example, like let's say this is your sample or device, and top view is like while we are looking from the top side, right? So you will be seeing this face, whereas cross sectional view is, let's say you take a cross section and then you see from the this side, like in this case the camera side. So you will be seeing this face, okay, this face. So let's say you need a particular structure which is this is the top view, this is a silicon wafer, and there we need two square wells. So one big, one small, two square wells. So this is the same material. Let's say this is the same material. This here also it is silicon, here also it is silicon, but both the silicon only, but it is etched. Okay, so let's say silicon is etched till total silicon wafer is about 500 micron thickness, and here it is etched about 2 micron or 1 micron. So you have two etched well where the silicon has been removed to a depth of 1 micron or 2 micron, and you can we can define some dimension to these lines also. Let's say this is about 10 micron, 10 micrometer, and this may be about 20 micrometer. And how the cross section will look like? Cross section will look like something like this. So this is the silicon, and then so I am taking the cross section along across this line. Across this line I am taking the cross section. So then you will be seeing some depth here. Again there will be the big or the larger well, like this, something like this, right? And this is the edge depth, which is, let's say we call it 2 micron. Now what we will do, we always start with a simple silicon wafer. Simple silicon wafer, how does it look like? This is just like, let's say this is our sample. So this is our silicon wafer, okay, and okay, silicon sample or silicon substrate you can tell, okay. So we start with that, and we will show step by step how we can achieve this desired pattern. Okay, so the first step is photoresist spin coating or PR spin coating. Photoresist or PR spin coating. Now after spin coating of photoresist, what will happen? It will be, photoresist will be deposited on everywhere. So let's say now photoresist is spin coated, so this is the PR layer, and it is coated over the total silicon sample. over the total silicon surface. So this is how the top surface will look like. Everywhere it will be coated with PR, and the cross section will look like a thin layer of photoresist or polymer will be coated on that. So this is PR and this is silicon. Okay. Now next level is, or next step is that expose with UV light according to our design. Okay, according to our design. So as I am saying that this will be like direct writing. Let's say we are talking about initially direct writing, right? And direct writing means I will be writing just like a pen. So this pen will move according to our required design. Okay, so that coordinates and all the information will be given to the laser writer or whatever system we are using, and then it will move the laser beam according to our required design. So let's first see which is the geometry like this. There we need a small square and there we need a large square. So this is geometry, and now I will move the laser beam. I will move the laser beam in this geometry. So this region, as you can see, this region is only exposed with the laser light, right? As I am doing manually, so it is not a complete coverage, but let's say while we will be using a system, then it will be a complete coverage, and this region will be completely exposed with the laser, and similarly for this region also, right? Similarly for this region also it will be complete cover. So it goes like this, that here only in this region we according to our design it will be moving. So okay, let's say we get this kind of coverage. So these two regions which are red is actually exposed with UV, and the other regions are not, right? Now what is the next step? Next step is that we develop and remove the exposed region. Okay, before I go to that, actually in the cross sectional image also I need to show then how it looks like, which region of the PR is exposed. So let's say like this, and then we have the big square. So, here it is Okay. Now, while we do development of this sample, then we know that this region which is exposed to UV, that has become, the polymer has polymer already broke there and became monomer, and that will get dissolved in the suitable developer solution. So this region will get dissolved and this will get removed. So let us remove this region. Okay. So polymer or PR has been removed from this region and this region, right. Similarly here also. So while erasing, just remove the silicon surface also, so I am just redrawing it. Okay. So now what we get? We get here one region from where the PR has been removed, the photoresist has been removed, and a bigger square also where the PR or the photoresist has been removed, the top region, and also in the cross sectional image also we get accordingly. Now what we do, we put this sample. So the next step is QH etching, or let us say we use TMH etching. So now if we do TMH etching of this sample, then what will happen, this region which is covered with the PR, that will not get etched because this is not exposed to the TMH solution, right, or KOH solution, whatever etchant we use. But this region or this region which is exposed to the solvent or to the KOH or TMH solution, that will get etched. So because of that, this region will get etched, and there the silicon will have some kind of etching depth in this region. Okay. So this is how the silicon get etched, and there we know that while we are doing wet etching, we get a shadow at the border, right, because of the 54-degree angle. So it will be something like this. Because of the inclined side wall, we will be having a will be seeing this kind of shadow region, what we have seen earlier in our slides. So this is the shadow region, and inside is etched, right. And how this will look like? This will look like this will get etched cross section, and then so this will get etched towards till that 2 micron, whatever was our requirement, and this angle is because of the anisotropic etching, right, and this is this 54.6-degree angle which we get for KOH etching or TMH etching from the silicon crystal structure. So the sample will look like this. Now, so once we have already, you see that we have already achieved whatever was our requirement. Now, but the PR is still remaining in the other region, right. So what we will do, we will just remove that extra PR, using solvent like acetone. Now acetone removes all the PR or the polymer which is here, but it will not erase, but it will not remove the silicon, right. So finally we achieved our required design or pattern using lithography.